Okay, so for today, we're kind of tacking on what we've been doing. You're going to be writing your own multi-step equations based upon what are called consecutive numbers. So the vocab is going to be in here, so you need your vocab, back it out. And then the examples will be in here. Then the problems that you're supposed to work are going to all be in here. So point out to pause and flip back and forth. Kind of like that. So we're going to try out and see what we think of that for a little while. So the only vocab term you have today is consecutive integers. It's integers that follow one another in an uninterrupted interval. What that means, watch this. The numbers 4, 5, 6, 7 are consecutive. They go in order. Boom, 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 right? Another example might be consecutive even. Ready? Watch this. 3, 5, 7, are you following me? 9. So those go in order, and those are consecutive odd, not even. That's funny. Well, you can have consecutive even, right? 2, 4, 6, 8. Those are all consecutive. These are just straight up consecutive, 4, 5, 6, 7. These are consecutive odd, 3, 5, 7, 9. And these are consecutive even, 2, 4, 6, 8. And those are simple examples. So there you go, consecutive integers. So pause here. You can keep your vocab packet if you want to. You don't really need it. Next, I'm going to have a few examples I'm going to work. And then you're going to pause it, and then you're going to work some in class kick, and then come back and check them. Alrighty, so moving forward. You know, I realize this says go back to class kick and work. You don't have to do that at this point. Right? So just pause, put away your packet if you want to, and then go on. Okay, so this is an example straight out of your book. This is the kind of word problem you're going to face. I know it sounds like a lot at first, but trust me, it's not a big deal. There's a really cool pattern to this. The sum of 3 consecutive integers is 96. Find the integers. So you have to guess, right? 3 numbers that go in order, like 1, 2, 3, but equal 96. Okay, so the sum by the way means add, don't forget that, is 96. So here's the real trick, watch this. My first number is called n, just straight up n. That's the smallest one. The next number is called n plus 1, right? Because if I go from 2 to 3, I add 1. The third number is called n plus 2. You call it n plus 1 if you wanted to. But again, it's n plus 2 because if I go from 1, 2 to 3, I got to add 2 to get that third one. Now here's the algebra part of it. This is kind of fun in my opinion. Your first number n plus your second number n plus 1 plus your third number n plus 2 equals 96. Now we know how to solve these, right? Go through, let's combine like terms. N plus n plus n, right? Down here, that's 3n. 1 plus 2, those are like terms, that's 3. So I really have to solve 3n plus 3 equals 96. We know how to do this, right? There's no distributed property right now. There's no combined like terms. We already did that. Subtract the 3, I get 3n equals 93. Divide the 3 that's attached here, I get n is 31. Now here's the thing, I asked for 3 numbers, not just 1. So if my first number is 31, right, and I go back and I add another number, that next one's 32, add another one, next number is 33. So 31, 32, and 33. Try it, add them together. Do you get 96? If you do, that's the whole idea, this reasonableness part here, right? Add them together, do you get 96? Yes, you do. That means I solved it. Now I'm going to work some. This was just to kind of get you to, warmed up for it. In the last one, you did 3 numbers, right? Oh, and here the answer's already kind of given away. I'm going to go like this so you can't see it. There you go. Alrighty, so it was kind of given away, but I don't want to do that. I want to go back and work them here. So here we go. 4 numbers I had to find. So my first number, and that's what we call let statements. Let n equal the first number, right? Next number, n plus 1 is the second. Keep counting with you, ready? Third number, n plus 2, that's the third number. This one says 4 numbers. So I've got n plus 3, not n plus 4, is the fourth number. You're always kind of one behind is the idea. So first number is n, next number is plus 1, right? N plus 1. Next number you're counting, n plus 2. Next number you're counting, n plus 3. Now, follow me with the pattern here. I have n, that's my first number, plus my second number, n plus 1, you follow me, right? Yeah. Plus my next number, n plus 2, right? Plus my third number, n plus 3. All those together equal, what did it say? Oh yeah, 358. 3, 5, 8. Now, that's the hardest part, seriously. Hardest part is how to write this thing. If you have one number, it's just n. Two number, n plus 1. Third number, n plus 3. N plus 2. Third number, I have to add on the n plus 3. Now, it's just an algebra problem. We've worked a lot like this already. So here's what we're doing. Like terms, n, 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 n. Where those each mean one n. So I have of those 1, 2, 3, 4. 4n plus, right? Plus 1 plus 2 plus 3. What is that? 1, 2, that's 6, right? Equals 3, 5, 8. Okay, pause for a second, kind of absorb that there. Okay, so what this really is now, it's just the multi-step equations. These are easy ones. Subtract 6, subtract 6. 4n equals 3, 5, 2. All right, now we're going to go and we're going to divide off the 4. Divide off the 4. N is 88. But I'm not done. That's only the first number. First number is 88. So my first one's 88, and we're counting in order. 88 plus 1, right, is 89. 88 plus 2 is 90. 88 plus 3 is 91. Now check that. Is that true? If you add those together, do you get 358? You do. So these are your answers right there. You have 4 answers this time. 88, 89, 90, 91. I think these are kind of fun. Okay, so here's where we're going to do a little bit of thinking, okay? Consecutive even integers. What does that mean? Even is like 2, 4, 6. Skip counting, some people call it. Okay, so follow me here when I do this. Let's pretend the first number was 2. The next number is 4. How do you get there? You don't just add 1 like, 2 to 3, right? You go plus 1. 2 to 4, I go plus 2. Now, by the way, this is the same for evens or odds, the same process. If I go from 3 to 5, right, I still add 2. Okay, so keep that in mind as we do this. So let's go back. I'm going to get rid of that. So find 2 consecutive even integers. So as we said, we write a let statement. Let n equal the first number. Now you might go, ooh, n plus 1. No, we're skip counting. Whether it's even or odd, it's the same. You don't go n plus 3 because it's odd. Even or odd, you do the same thing. N plus 2 is the second because we're skip counting. This says I only have to have 2 of them, right? If I had to have 3, I'd go n plus 4. Another one would go n plus 6, n plus 8, right? So that's not what we're doing, though. So I have 2 numbers. I have n, right? And then n plus 2 is the second number. It says all that equals 66. That's the hardest part, is writing this dang thing. So, like terms, n and n, right? 1n and 1n is 2n. Bring down the plus 2 equals 66. Now it's just our multi-step equations. Minus 2 minus 2. 2n equals 64. And then we divide off the 2, divide off the 2, and I'll give you just a second. You got it. N is 32. So the first number is 32. The second number, we were skip counting, that's 34. Now you got to check that. What's 32 plus 34? You betcha, that is 66. So my answer is 32 and 34. Okay, I made one up a little bit tougher. 3 consecutive odd integers whose sum is negative 9. Now this works just the same. The first number is n, so let n equal the first. Again, we're skip counting. I know odd, you want to go, oh, n plus 3. No, you're still going from, let's say it goes 1 to 3 to 5. You still only add 2 every time. So n plus 2 is the second. Third number, n plus 4 is the third number. Okay? And their sum is going to be negative 9. This one's kind of fun. Okay, so you ready? We're going to start out with our first number, n. Second number, right? N plus 2, that's right here. Third number, n plus 4, because we're skip counting. All that is negative 9. Now, that's the hard part, is getting that equation right. Now, the addition. 1n, 2n, 3n. 3n plus 2 plus 4 is 6 equals negative 9. Okay? Now, just our regular good old-fashioned multi-step equation. Subtract 6, 3n equals. Now, you got to be careful of your integer operations here, right? You're already 9 in the whole, take away 6 more, right? Doesn't become 3 or negative 3. It's negative 15. Divide off your 3, divide off your 3. N is negative 5. Here's, you got to be really careful, okay? Because my first number is negative 5. My next number is negative 5 plus 2, right? Isn't that what it says right there? My third number is negative 5 plus, oops, that's not a very good 5, plus 4, right? It says it right there. So negative 5 is negative 5, right? Negative 5 plus 2 is negative 3. Negative 5 plus 4 is negative 1. Okay? So those are my three numbers. Now add them up. 5, negative 3 is, it's negative 8. Plus 1 more is negative 9. Yay, it worked. So negative 5, negative 3, negative 1. These are kind of fun. You can go back and look at this thing 100 times if you want to. Okay, so here's where you pause. Go back to class kick. Work the practice problems. I have 4 for you. Took them pretty much straight out of the book. On page 351, 10, 11, and 22 is really where they come from. So if you want to check those later or whatever, write them down somewhere. Then come back here and check for the answers. So pause, and then come back, please. Okay, starting out nice, easy examples. It's nice and easy, rather. The sum of two consecutive integers is 131. Okay, two consecutive integers. So first number is n. So let n equal the first. That's an ST, I promise it is. That's not a very good ST. Let's make it a nicer ST. 1 ST. Second number, again, these are not odd and even, it's just consecutive. So n plus 1 equals the second number. Just two of them. So n plus 1 equals 131. Now, combine like terms. N, and n is 2n plus the 1. That should be a box, shouldn't it? Equals 131. Subtract the 1, 2n equals 130. Divide the 2, n equals 65. You don't believe me, divide it out, right? So first number is 65. Next number has to be 66. Add them up. Does that equal 131? No, it does, trust me. So 65 and 66, put it down here again, and 66 are your two answers. If you didn't get it, go back and check. Or again, you can raise your hand in the app. I can come around and help, whatever you need. Okay, so the sum of three consecutive even integers is 60. Remember, it always starts out the same, folks. Let n equal the first number. Okay? Now, next up, let's see the word let, I promise. Since we're skip counting, it doesn't matter if it's even or odd, we're skip counting. So the next number is n plus 2. That's the second number. And again, we're skip counting. N plus 4. That's the third number. Always, 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 always skip count. I don't care if it's even or if it's odd. That's what you do. So, to write it up, first number n plus second number n plus 2, right? Right there. Third number n plus 4. All of that equals 60. Now, combine like terms. 1, 2, 3 n's plus 2 plus 4 is 6 equals 60. Now it's a nice multi-step equation. Subtract the 6, 3n equals 54. Divide off that 3, people, like we've learned to do, and we know that our answer is n is 18. Now, not done there, right? First number is 18, consecutive even, 18, next is 20, next is 22, and check it, add them together. Is that true? Is 18 plus 20 plus 22 equal 60? And it does. There's our answer. If you need help, raise your hand in the app. I'll be right around. All right, this one's fun. 4 consecutive integers. Okay, you ready? So, let n is the first, right? And then n plus 1. No, we're not skip counting this time. Is the second. N plus 2 is the third. N plus 3 is the fourth. Let's make sure, is that right? So we're consecutive, not skip counting. N plus 1, n plus 2, n plus 3. Yep, that works. Okay, so let's add them all up. My first number, n, right there, right? My second number, n plus 1, right there. My third number, n plus 2. My fourth number, n plus 3. Now, it seems funny that we're like one behind the whole time, but you are. Equals negative 22. Combine like terms. 1, 2, 3, 4 n's. Plus 1, plus 2, plus 3. What is it? 1, 2, 3. 6, right? Equals negative 22. Now, just the kind we've been working. Subtract your 6, subtract your 6. You got to be careful here when you're subtracting. Negative 22 minus 6 more. It's technically Ninja Disco minus 28. Right? Got to watch that. If you didn't get that, you may want to go back and refresh yourself on your integer operations. So, anyway, now divide off that 4. Don't lose your negative. N is negative 7. Now you got to ask yourself, so if n is negative 7, right, n plus 1 is negative 6, n plus 2 is negative 5, n plus 3 is negative 4. Does that work? If I add these together, do I get negative 22? And you do. So there you go. I think these are kind of fun. I really like them because it's like brain thinking, challenging, fun stuff. All right, there you go. Oh, and before I forget, homework today is a worksheet double-sided. One side is fortune teller, right? It's one of those daffy kind of, decoder things. You got some multi-step equations. The other side is this stuff, consecutive integers. All right, have fun.